Hello everyone. In the previous lectures, we had a look into various electrical methods of investigations. To be specific, we had a look into electrical resistivity methods, and we had also seen couple of case studies on the applications of electrical resistivity methods. Today, we are going to perform electrical resistivity investigation at IIT Madras. Before commencing our field work, I would like to recollect there are the three methods of carrying out the survey in the field. One is profiling. In profiling, we will shift the electrodes in a sequence along a profile, right. That means our aim is to understand the lateral variation in the subsurface. Second is the vertical electrical sounding, in which we will progressively increase the electrode spacing by keeping the common point constant. This point will remain constant. We will spread the electrodes on either side so that the depth of penetration will increase. This is what is known as electrical sounding. Third one is the combination of both. We have seen already. Today we are going to perform vertical electrical sounding at IIT Madras. So, before moving on to that, why we are going for vertical electrical sounding? In vertical electrical sounding, we would like to increase the depth of penetration of the current. How we can achieve that? As I told you, we have to increase the spacing between the electrodes progressively. Now, the electrodes are kept at 10 meters, now the electrodes are kept at 50 meters, especially the current electrodes. So, these are the 4 electrodes. A and B are the current electrodes, potential electrodes are referred by M and N. The spacing between current electrodes will be progressively moved, right, in order to increase the depth of penetration of current. So, this is helping us to understand about the variation in the apparent resistivity below the surface of the earth. So, depth of current penetration is high when you have obviously a low resistivity layer, right. When the lower layer has got low resistivity, then penetration of current will be much higher. Depth of current penetration is low when the lower layer resistivity is very high. For example, there are two layers. When the resistivity is low, more current will pass here. When the resistivity of this layer is high, the current will be restricted only to the upper layer, isn't it? So, though we try to understand about the depth of investigation by increasing the penetration of current, it also depends on the resistivity of the layers below the surface of the earth. So, this is how we progressively increase the depth of propagation of current below the surface of the, and similarly with regard to area of investigation, these slides we have already seen, right. When you have the electrode spread something like this, our area of investigation is actually this triangle, right. So, if you want to increase the area of triangle laterally, then it is profiling. If you want to increase the area of triangle by increasing the depth of penetration of current, then that method is known as vertical electrical sounding. So, today we are going to perform vertical electrical sounding. How vertical electrical sounding is going to be performed? By progressively increasing the spacing between the electrode, but the center point remain the same. This point remain the same. That is the point of our investigation. Though we are going to place the electrode on either side, our point of investigation is this. That means just below that we are going to determine the variation in the apparent resistivity. That is what is the vertical electrical sounding. So, we are going to carry out the vertical electrical sounding the campus of IIT Madras. So, here are some video we have taken during this. So, that is what I am going to show you now. So, what we have done is, first we have measured and placed a measuring tape, or in this case we have kept a electrical cable which are marked with a tape, right, indicating the distances. I hope you can see. Yeah, just now we have seen a yellow cello tape was put at every meter. So, what you see is the resistivity meter in a black box, and the cables, you can see 4 cables here two cables are in red color, another two sets of cables are in black color. The black ones are the ones which are used for potential electrode, so their length is little bit lesser, right. Usually we do not extend the potential electrodes beyond certain distance, right, that is the reason, right. Whereas the ones which are in the red color are used for current electrodes. Hope we have been seeing current electrodes are kept at a distance which are much higher than the potential electrodes. Today we are going to perform vertical electrical sounding by making use of Schlumberger method, right. What is Schlumberger method? In Schlumberger method, the spacing between the potential electrodes are very less, whereas the current electrodes are much higher, right. That means the spacing between the current electrodes is greater than 3 times of the spacing between the potential inner electrodes or potential electrodes. We are going to perform vertical electrical sounding. So, in vertical electrical sounding, we need to progressively increase the spacing between the electrode. Our center point of the spread is just on the other side of the resistivity meter, which you see. On the other side of the resistivity meter is the center point of our electrode spread. In other words, approximately the resistivity meter is kept at the center. The electrodes are on either side now, right. The electrodes are on either side. In first, we are commencing our measurement by keeping the potential electrode at a half a meter from the center of the center. Then you can see the straight line, right. Along the straight line now we have, I hope you can see my cursor. So, along this red line are going to be our placement of electrodes. So, initially we have kept the potential electrode very closer. We are going to commence our measurements by keeping the first A and B distance was 3 meter from the center. So, AB by 2 is 3 meters, MN by 2 is half a meter. Now, we are going to press for applying the current. So, resistivity meter has a source which is kept adjacent to that, which is nothing like a regular conventional battery which we use for our UPS at home or in our automobile. Such a battery is used. When you press for current, the current is now passing into the earth. So, before that we can also set the distances of the electrodes in the resistivity meter, so that we need not carry out any calculation. That means, the distance between A and B are fed, as well as distance between M and R actually indicated at the instrument. That means, we set the distances beforehand, then we carry on with the measurements, right. So, since the distances are already given as an input in the instrument, it will directly determine the value of rho A. So, rho A is equivalent to electrode constants multiplied by the resistance which we measure, right. V by I is R multiplied by the electrode constant. Electrode constant, it automatically calculates because we have fed in the information of the distances between the electrodes. Now, a measurement of apparent resistivity has been taken for a particular electrode configuration. That is what is being indicated in the resistivity meter, right. So, this resistivity meter directly gives the value of apparent resistivity, and the resistivity meter has got several other functions. So, that means we can also vary the amount of current which we are going to apply into the earth, because at some locations where, as I indicated just now, when the resistivity of the layers below the surface is very high, we need to apply more current, or we need to facilitate the flow of current. Sometimes we may need to add some little bit of water in the current electrodes, or we may need to use a very long current electrodes. For example, when we carry out the survey in the coastal areas, right, where we have dry sand, we need to we may use 4 or 5 foot long electrodes for the propagation of current into the earth. So, here we are going to now, after taking one measurement, our students are shifting the electrode to the next distance. That means, first we have completed AB by 2 was 3 meters. Now, we are going to increase it to AB by 2 has been increased to 6 meter, right. So, this is the next measurement we are carrying out. So, electrodes as you see are nothing but a metal rod. So, in this case we are using a stainless steel rod. Electrode has been kept in place. So, it has to go at least about 10 to 20 centimeters into the earth, so that there is a good connectivity between the electrode and the resistivity meter, right. So, a resistivity meter, this cable runs through the winch. You have seen a long red cable wound on a spool, right. Through the spool, the electrode is connected to the resistivity meter. So, on either side, now we have increased the distance between the electrodes. On either side from the center, A and B are now at a distance of 6 meters, right. After planting this, we will take the next measurement, right. So, here to carry out the survey much faster, we are using additional rods. So, by the time the measurements are taken, the new electrodes will be kept at 9 meters, then we will just reconnect the cable to that, right. Now, AB by 2 is at 6 meters, we are carrying out the measurement of apparent resistivity, right. Apparent resistivity is measured using the resistivity meter, as you can see here, right. So, the resistivity measured is directly displayed. So, we are able to also determine, sometimes in this meter directly also gives the approximate depth of layers, right. But here we are just noting down the resistivity values carried out during the survey. So, the resistivity values are now noted down. After having noted down the resistivity values, right, the next measurement is now being taken. As I told you, the next electrode was already planted, right. Since the flow of current was not sufficient, we are doing little bit of hammering, right. Now, A and B are at a distance of 9 meters. So, this is how we are now carrying out the survey to understand the variation in apparent resistivity at different depths below this particular point within our campus, right. The point of our observation is just in front of the resistivity meter. What do I mean by point of observation? That is the center point of the electrode spread. So, from the center, we are progressively moving symmetrically we are moving the electrodes on either side from the center point. A is moved on this side, B is moved on the other side. So, this is how we progressively move the current electrodes. As we move the current electrodes, sometimes we may not be able to get sufficient potential, because when the current electrodes are very far compared to the closer distance between the potential electrodes, we may also need to progressively move the potential electrodes also, right. So, that means when we are shifting the current electrodes, let us say every 0.5 meter or 1 meter or 3 meter, let us imagine now the current electrodes are at a distance of 12 meters. Previously, we started keeping the potential electrode at a distance of only half a meter from the center. So, this may not be sufficient to pick the potential. So, what we are doing is, we will also progressively shift the distance between the potential electrodes. Okay. So, that means now you can see the red wire is connected. So, this is a current electrode. We are progressively moving the current electrodes on either side of the spread. After some time, the potential electrode also will be shifted, but we will repeat the measurement for the same distance between A and B. I will tell you little later, right. So, now we have kept the new distance. Now, we are entering the distance at which we have kept the electrodes. Then we are going to make the measurement, right. After entering the distances, we are going to apply the current. When you apply the current will pass into the earth. The meter will directly give the reading of apparent resistivity, right. and the resistivity meter also has a facility to carry out the measurement number of times, right. So, it has now directly give the resistivity value 1.419, right, and the resistivity meter is capable of automatically nullifying the effect of cell potential. Most of the modern day resistivity meters will automatically nullify because the resistivity meter measures the potential. Actually, there will be a natural potential also which will be subtracted during the measurement, right. After continuing for some time, right, and the meter can also, you can set the meter to make the measurement 4 times, 8 times, 16 times like that. That means it will repeat. There can be some minor variation, so it will give the average as the final value, right. However, it will take more time. If you choose 64 times, obviously the time which we are going to spend at the field will be much more, isn't it? So, in here I think we are doing at 4 time measurements only we are doing. So, 4 times it takes the measurement and gives the average. So, this is the line on which we are progressing on one side. On the other side too, the other set of our students will be now moving the electrodes. So, this is the current electrode is being moved, and then we are going to connect the current electrode with the cable, then the measurement will be taken. So, this is how our students are one after another, they are learning to take the measurement using the resistivity meter. So, as we move progressively beyond certain distance, we will also increase the distance between the potential electrodes. I will tell you how we are going to do that, right. So, this is how we are carrying out the survey, right, at the site. So, one after another measurements are being taken, right. So, next set of student is taking the measurement. Now, you can see though there are many electrodes, as I told you, we are using a kind of duplicate electrodes. Hope you can understand, right. That means, at a time only 4 electrodes are connected to the resistivity meters. That means, what are the 4 electrodes? 2 are current electrodes, 2 are the potential electrodes. So, this is how we are carrying out the survey in the field, right. So, next set of student is now taking the measurement. So, here you can see the resistivity meter also approximately gives the depth of the layers as we progress the survey using the resistivity meter, right. So, we have gone almost to the end of the survey line. So, I think we plan to carry out the survey up to a distance of 60 meters, that means 30 meter on either side. So, the depth of penetration will be approximately 30 meters now, right. So, as we move progressively, you can see the spool of current wire here, current electrodes wire here. The other end of this spool is connected to the resistivity meter, right. You can see we can plug into the resistivity meter. The other end of this spool's wire is connected to the electrode. So, this is the data table in which we are noting down the apparent resistivity, right, as we progress. So, apparent resistivity is being noted down on the resistivity on the table which we have, right. So, as we are moving progressively along a line, we also be moving the potential electrodes, right. So, this is how we have carried out the survey at IIT Madras using the resistivity meter. So, you can see this is how progressively the electrodes are shifted on either side, right. So, and each set of students carry out the measurement. So, what I was referring to is, so when we are carrying out the survey, right, in order to carry out the survey little bit faster, what we are doing is, this is the site, this is the cross section, this is the surface, this is the center point of the spread. These two are M and N electrode, which were kept initially at 0.5 meters, right. Current electrodes were kept initially at 2 meters from the center. So, this distance is 2 meters. Similarly, on the other side 2 meters. This are referred as A and B. When a set of people are taking the measurement, the next electrode may be at 3 meter is actually hammered, it is kept ready. Okay. As soon as the measurement is over, the cable which was connected to this is removed and connected here. That is what we were doing. Though you see more electrodes, we are at any time we are using only 4, but in the field there are 6 electrodes. The other 2 electrodes are simply when they are taking measurement using this configuration, the electrode here will be removed and then shifted to the other side. Okay. So, this is how we are increasing the electrode spacing. As I had told you already, that data which we collect from the field will be something like this, right. So, what is the data which we collect? So, first is the distance between the potential electrodes. Normally, for convenience, we write as Mn by 2 AB by 2. Why? Because the electrode constant is dependent on pi by Mn AB by 2 whole square minus Mn by 2 whole square. Okay. So, in order to apply this into this relationship, we used to conventionally write as Mn by 2 and AB by 2, but modern day resistivity meter we do not require all these things because we are going to feed in this information into the resistivity meter. As you had seen, right, there is a provision, there is a keyboard using which we are entering these distances, right, 2 meters. These are all in meters, right. The instrument directly gives the apparent resistivity, ohm meter, right. So, we note down the resistivity, then we increase the distance to now let us say 4 meters, 6 meters. So, this is how we increase the distance between the electrodes, and we have noted down the values, right, 8 meters. After this, right, we would like to also increase the potential electrode spacing. Now, potential electrode is at 0.5, AB by 2 is at 8. Now, we have increased the potential electrode distance to 1 meter. When we increase the distance between the potential electrode, we will keep the distance between A and B at the same, right. Why we are doing like this? The apparent resistivity which we get here should be similar to that of here, right, because we have moved only the potential electrode now. Because of that, we should have got more or less the same value which we got here, but many times we will not be getting like that. There will be some marginal difference, that is the idea, just to verify that, right. Then we will continue 10 meter or every 3 meters depending upon the condition, right. It is flexible, we are going to decide about this. After that, again this is at 16, we do not move this, but we will increase it to let us say 3 meters. This is how we will continue carrying out the survey. That means, by carrying out this survey, now we have got what data? This refers to the depth. Hope you can recollect, this is what we had seen here, right. The electrode spacing directly refers to the depth of penetration. When the electrode spacing was 10 meter, this was the depth of penetration. When it was 50 meter, it goes up to this. So, what we have done here is practically we have this refers to the depth, this refers to the corresponding apparent resistivity value. That means, when the electrode spacing was closer, current was passing only up to this. When electrode spacing was here, it went up to this. When electrode spacing is increased, it goes to the greater depth. But remember, because we have kept the electrode here, we do not imagine that we are measuring the apparent resistivity of this zone. We are measuring the combined resistivity of the entire zone, right. That should be kept in mind. Whereas, when the electrodes are very close, we are almost measuring the true resistivity of the layer very close to the surface of the earth. Whereas here we are only certainly measuring the apparent resistivity of the, which is the combined effect of all the layers from here to here. Okay. So, now we have got a data of AB by 2 versus rho A. This is what we were using for interpretation, right. So, now what we are going to do, we will plot the resistivity curve. Resistivity curve is nothing but AB by 2. Why we are using AB by 2 here? Since we have used Schlumberger method. Schlumberger method is always advantageous when you carry out the survey for vertical electrical sounding. So, rho A versus AB by 2 data, right. So, we have got a table which I have already indicated in the previous page, Mn by 2, AB by 2, correspondingly the rho A value we have, right. This is what we have drawn, right. So, this table is going to be made use of. The AB by 2 versus rho A data is plotted. So, when we plot, we will get several segments. We will have 4 lines. Then I told you we are repeating. Initially we kept at 0.5 and then we are varying the AB by 2, then we are increasing it to 1. Here we kept at 8, here also 8 meters, right. The value of rho A should have been the same. What we get here should be the same, but it may not. So, there will be some minor, though it has to get plotted at the same place, it may not. So, another set of 5 or 4 values we have taken. Then we are moving the potential electrode. See here it may be little bit higher also, next to 4. Then we have changed the potential. This is how our data points will get plotted. So, this is what is known as resistivity curve. This curve is being interpreted in different techniques I explained to you previously, right. You instead of this you can also convert this into some right cumulative frequency. In that case the method is inverse slope method. Let us see a conventional curve matching. So, in curve matching what we are going to do? So, this we are going to plot the curves in segments, that is the best way according to me, right. Then you can think of plotting a curve something like average in between. So, this is the final curve, right. This curve can be matched with the type curve we have. The curve can be directly interpreted. So, how can we carry out the interpretation? That is the first method, asymptote. So, what we can do, where is the major change in the slope of the curve? So, I will say somewhere here, right. Maybe here is the major change in the slope. Here too there is a major change in the slope of the line. Now, I will interpret this refers to approximately the depth of investigation. Let us say here you have 5 meters, here we may have 10 meters. So, usually it is also done on log, right. If it is so 1, 10, 100. Okay. So, here we did only up to 30 meters. So, our curve will be only up to this, right, not only up to this, right. But anyhow, for understanding you can take it that we did up to 120 meters or 150 meters, right. So, let us say that this is the first layer, layer 1, this is layer 2, this is layer 3. This is how we can interpret the approximate depth of the first layer is 1 meter, second layer goes up to 10 meters. So, this is how by looking at the resistivity curve we can interpret. Since the campus of IIT we have massive rocks below the surface, right, we have some soil may be up to 1 meters, 1 or 2 meters or maybe up to sometimes up to 8 meters, right. Then we have weathered rock, then we have fractured rock. So, this is the typical curve which we will get in when you carry out the survey in the hard rock. So, this refers to the top highly weathered regolith which is soil. This is the weathered rock zone, this is the weathered rock zone, beyond that is the fractured rock. So, this is how a vertical electrical sounding can be carried out at the field and the interpretation can be made. Here we have seen just a interpretation by drawing a resistivity curve. Same data can be given as an input to you 1x 1D software, right, or there are several other software that are available which will work on the principle of inverse modeling, right. That means this is the data we have, the computer will try to match this data by arriving different geological configurations, right, or some of the methods simply make use of the software to compare the type curve. In any way the interpretation can be done. Hope you would have had a glimpse of carrying out the vertical electrical sounding at a real field situation. Thank you.